All right, so this is section 11.5. We have this example here. All of these people here have been invited to a dinner party. They arrive randomly, and each person arrives at a different time. We want to know in how many ways can they arrive, and how many ways can Maria arrive first and Sarah last, and then find the probability that Maria will arrive first and Sarah last. So let's go ahead and just take a little picture of this. I'm going to screenshot here, and I think it's actually easier to write on a PowerPoint. So first of all, this whole section has combinations and permutations, if I'm correct. So it's a little more challenging because you don't know which one it is, right? Do you remember the difference between a combination and a permutation? So combination and permutation, they both deal with the different ways that we can arrange things. But for permutations, order matters. Combinations, order does not matter, which kind of goes against what you think. Like in everyday life, right? You use a combination lock and you're putting the numbers in a certain order, aren't you?
Mm-hmm.
So it's like you have to think it's the opposite. So with combinations, it doesn't matter. If I have the set 1, 2, 3 like this, that's going to be the same as 2, 1, 3. That's the same combination. Okay. But for permutations, it's going to be different. These are two different permutations. Make sense?
Mm-hmm.
Okay. So this is one combination, but two permutations. Let me actually take this off. Sorry if it's a little bit sloppy. All right, so that's the difference on it. So permutations, order matters. So then whenever you have, different ways something can happen, you're always going to have more permutations than combinations because you can rearrange them differently, the same things. So when it's asking how many ways can they arrive, is that a permutation or combination?
Permutation?
Yes, it's a permutation. Why? Because order matters, right? You're going to get a different order. The different people arriving, right? Like Maria coming in, like imagine if they're standing in line, you're going to have a certain order of the people there, right? Or if they rearrange themselves in line, then that's a different order of people. Okay, so permutation because order matters. So with permutations, you can just multiply. So how many people do we have? 1, 2, 3, 4, 5, 6, 7, 8. So do you remember that that's going to be 8 factorial?
Mm-hmm.
Do you remember what factorial is?
The multiply?
Yes. So it's 8 times 7. And your calculator will do this for you. Do you have like a little scientific one that you use on your test?
Yeah.
This is a really, really big number. And it seems like there's no way you could rearrange them that way. But you really can. You can. Because it would be, for instance, if you have Maria first, Maria, it could be Maria, then Eduardo, then, people in order down the row. It could be Eduardo first and then Maria and a bunch of different, it splits off to a bunch of different possibilities. So what's one way they can arrive?
I don't know.
Okay. You could have this like it's written right here, right? We could have Maria come first, then Eduardo, then Dawn, Katrina, Ian, Sergio, Kim, and Sarah. That's one way,
Mm-hmm.
right? Another way would be Eduardo, then Maria, then Dawn, then Katrina. You get my point? So those are counting how many of those different rearrangements of them. And so that's why this kind of works out. So if I've got for the first position in line, say they're standing in line, you have 8 people to choose from, right? And then one person is going to stay in that spot. And so for the second place in line, then you only have 7 people to choose from, right?
Mm-hmm.
And then for the third place, we imagine they're stuck now there, right? Whoever they put there, then you've got 6 people to choose from. And it just keeps reducing the amount of choices the further down the line that you go. Does that make even more sense now?
Yeah.
All righty. So then let's go to part B. So for part B, I'm just going to draw part B like that. It says, in how many ways can Maria arrive first and Sarah last? And so all that means is that we have 2 fixed spots. I like to do this when I'm teaching it in class, the physical classroom. I tell the students to write blanks for each of them. So there's 8 people in line, right? 1, 2, 3, 4, 5, 6, 7, 8. Okay, and so that's the order that they come in. Now, it says the first one has to be Maria. So for the first space, we no longer have 8 choices, only 1, right? And for the last space, we only have 1 choice, Sarah, huh? Make sense?
Mm-hmm.
So if those are fixed in those spots, then we really only have 6 other little, sections where it can happen so this will be, for this spot, we have 6 choices. And then one of the people, maybe Eduardo's here, and so he's no longer a choice. And then here in this spot, we have 5 choices. Maybe Katrina's there, so she's no longer a choice either. You get what I'm saying here? And this one, you have 3 choices, 2, and then down to the last person. Does it make sense?
Yeah, I get it.
You got it? Okay. And then we can just see whatever that equals. We'll do it in a minute and we'll check it in my lab. And then to find the probability that Maria will arrive first and Sarah last. So probability, now we take the one that you want over how many possibilities there are. So the probability is equal to, we'll just say probability of E, I guess, the event that we want, right? Okay, so the probability of our event, and so the event, we're going to say E is the event that, this is the event that Maria arrives first. And Sarah last. So that can happen a bunch of ways, what we just saw, right? And whatever this number is. Let's see, 6 times 5 is 30, times 4 is 120, times 6, because that's what this is, right, is going to be 720. So there's 720 ways where you can have Maria first and Sarah last. Which is actually 6 factorial, really, because of these. It's just 6 times 5 times 4 times 3 times 2 times 1, because these ones don't really matter, right? And so the probability of E is going to be the number of possibilities for E, which is, we'll write that down in a minute, the 6 factorial or 720. And that's going to be by the number in the sample space. We'll just say S for sample space. So all of the different permutations that we have, and that's going to be this number here, all the different arrangements. Okay. So this is going to be for the top, for part B, it was actually 6 factorial, right? And I'm writing it this way on purpose because I want to show you how to simplify if you don't have a calculator. And then the top one, the total amount of permutations, right? The total amount of ways that they could arrive at the restaurant is 8 factorial. And so, and you always have a bigger number on the bottom. Remember, probabilities can only be between 0 and 1. 0 means that it's certain to happen. I mean, sorry, 0 means that it can't happen, and 1 means that it's certain to happen. So, but what I'm going to do here is I'm going to erase, I'm going to show you something, and then I'm going to show you how you can erase. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 8 factorial is 8 times 7 times 6 times 5 times 3 times 2 times 1. Well, can you see that 8 factorial is 8 times 7 times, this is just 6 factorial here? I know you can't answer because I asked you to turn the mic off, so, but usually that's what I show the students, right? So you have the same thing here. But instead of doing all this work, I don't want you to do that. I'm going to go backwards. I want you to learn to do this. Hopefully my computer will let me. Yeah, it got limited on what it would undo. Okay. I want you to be able to say 6 factorial over 8 times 7 times, instead of 6 times 5 times 4 times 3 times 2 times 1, 6 factorial. Okay. That's what you want to do. And then you can start simplifying. We've got 6 factorial here, 6 factorial. And our final answer is we have 1 over 8 times 7, which is 56. And I don't know what my lab wanted, if they wanted what kind of answer they wanted. And this is where you have to be careful. Okay, so they'll tell you the integer. Now for 8 factorial, that one's a little bit ugly because you're going to have 720 times pretty much 56. So that's one you want to do in the calculator. So we're going to do our probability here, 8 factorial. We're not doing the probability, we're just doing part A, the permutation. So if I want 8 factorial, we're going to go 8 and we're going to go to math. And right now we're working on probability. So a lot of stuff's going to come from this one. We go over here and it's number 4. So that's a pretty big number, 40,320. So that's going to be the answer for this one. What was it? 40,320. Okay. That's all the different ways that they can arrive at the restaurant. That's so mind-blowing, isn't it?
Mm-hmm.
It's mind-blowing. And then for part B, that one we just did in our head. We don't need the calculator, but if you wanted to check it, you can. Just for practice. Okay, so you do 6 and then you go to math, probability, and number 4. Okay. Now for that last part, that one was, we need a fraction, right? So we do alpha, y equals numerator over denominator, or like this. And we're going to do 6 factorial. For the scientific, they have a button like that as well. Oh, I hit the wrong thing. 6 factorial. Number 4. Over 8 factorial. And that's number 4. And there's our 1 over 56.
One.
Hmm?
Oh, nothing.
Oh, okay. All right, so we can go ahead and put that into my lab, and then do you have any questions on this little part?
No.
Okay. All right, so this was what, 40,320? Was that right? 1, 2,
Yeah.
3, 5, 6, 7, 8. Okay. And then we put here was 720. And then the other one. So this one wanted just a fraction. You always want to make sure how they want the answer, because I see a lot of that when I go and grade, the student puts a decimal instead of the fraction, right? So make sure you put it. Uh-oh. I got 1 over 52, or did I put the wrong thing? Oh, 1 over 56. I put the wrong one. Now I'm not going to have 100 on my assignment. Okay. 1 over 56. There we go. All right. Yeah, this is a good one. It's a little bit different. Okay. So let's take this one over here. So this one says a group consists of, we've got 5 Democrats and 6 Republicans. 3 people are selected to attend a conference. So you're choosing 3 from those, right?
Mm-hmm.
And how many ways can 3 people be selected from this group of 11? So, and how many ways can 3 Republicans be selected from 6 Republicans? Find the probability that it will be Republicans. Okay, so choosing 3 from the group of 11. Is the order going to matter here?
No.
No, it's not in a certain order, like line, right? Okay, good. So then if it's not, order doesn't matter, is this a combination or permutation?
Combination.
So this is where we've got 11, right? And we're choosing 3. Now, for this one, it's always going to be, the formula for this is n choose r, right? R is how many things? It's always n factorial.
Divide.
Divided by.
N minus R.
And
then factorial.
And?
Then R and factorial.
Yes. All right, and so in this case, n is 11, right? For this one, n equals 11. I'm just going to write that. And we're choosing 3, so r is 3. All right. So this will be 11 factorial, and this is where I think it's kind of fun, like simplifying. So just let me know, like, if you want to practice one of them in front of me, you know. Okay. Instead of me just writing. Okay, so we got n minus, I'll just let you like answer and stuff. So instead of talking more. All right, and then I've got this here. All righty. So this is just, you know, simple here. So I've got 11 times 10 times 9 times, and I'm going to stop it at 8 factorial because down here, 11 minus 3, that is 8, right? 8 factorial. And then we've got 3 factorial. Now 3 factorial, I usually go ahead and break this down. So that's 3 times 2 times 1, right? Because these numbers usually go into some of the other things that are there. So 8 factorial obviously goes away. 1 doesn't matter, that's right. 2 can go into 10. How many times?
5.
Yeah, very good. And then 3 goes into 9 3 times. So then we have 11 times 5 times 3. Well, that's all we have, right? I'll put over 1, I guess. But 55 times 3, so what is that, 165?
Yeah.
165 ways. Okay. Do you have any questions on part A?
No, I'm fine.
Okay. Is part B a combination or permutation? Does order matter on part B?
No.
Again, it does not. So this is a combination again. You want to tell me what to write on this one?
Do we use the same formula?
Yes, but now it's from 6, right?
So n is gonna be 6. And r is gonna be 3. Yeah.
Okay. And then so 6, choose 3. So it's just 3 factorial. Well, you could do 6 minus 3 if you want to, but 6 minus 3 factorial times 3 factorial. So that's going to be 6 times 5 times 4 times 3 factorial over, we have 3 factorial. And then we've got 3.
Times 2 times 1.
Exactly. And so we can just start canceling some things again. And 3, 2, and 1 is 6. So that should give us just 20. All right, the last one says find the probability the selected group will consist of all Republicans. So we've done all the work for part A and part B. So how do we put part A and B together to help us solve this problem? To help us solve C.
Do we subtract the numbers?
Well, we're trying to find for it to be Republicans. We had that it would be, there's 20 different ways for it to be Republican, right? There's 20 ways to arrange the Republicans. That's what we got for part B, right? Okay. And then we got from part A that was 165 ways to choose 3 from all 11 of them. So of those 165 ways, right, those 3 different people from the whole group, to only 20 of them will be all Republicans because that's what we saw here, right? So it's gonna be 20 out of this. Does that make sense?
Yeah.
This is the total sample space here. It's kind of like the last question on the other problem. I feel like that's a higher level one. Students have trouble sometimes putting that one together, but so we want the probability that it's Republican. I'm going to put R for Republican. So it's the number for and the combination for Republicans, right? The number in 6 choose 3, right? Divided by the number in, or we can just say divided by, let me just write it this way. Make it nicer. Okay, so the number Republican combinations. I'm going to actually write it out. Over the number of the sample space. We'll just say sample space. Or just both. Okay. So that's going to be 6 choose 3 divided by 11 choose 3. All right. So we have 20 over 165. So when we simplify this, 5 goes into 20 4 times, and it goes into 165 33 times, right? And that's it. So then we can go ahead and put this in MyLab, and then we'll, and do you have any questions before?
No, I'm okay.
Okay. So 165, 20, and 4 over 33. We had 20, and we had 4 over 33. And you always want to reduce it too. Like it'll say, see how it says simplify answer? If I simplify, it will count off. And I already have a bad grade because I put the wrong answer earlier, right? I don't think it's counting that anyways, but let's say that I didn't do that. If I did this. Oh, well, that's all wrong now. Then it's going to count it wrong because it wants us to simplify. So we have to do the 4 over 33. Okay. All righty. I guess we'll look and see what other ones. This is in one lottery, a player wins the jackpot by matching all 5 distinct numbers in order, any order from the white balls. So white balls are 1 through 43. It says any order on those. I'm then matching the number on the gold ball, 1 through 54. If one ticket is purchased, what's the probability of winning the jackpot? Does this look like one that you want to try?
Yeah.
This one. So one lottery, a player wins the jackpot by matching all 5 distinct numbers drawn in any order. Okay, so it doesn't have to be in a certain order on this. So is the first part a combination or permutation?
Combination.
Yes. So you have, for this little piece, let me, okay, so this part is going to be, you want to tell me what it is?
And 43 and R1.
5, right? 5 distinct numbers?
Yeah, 5.
5. Okay. So it's 43, choose 5. Okay. Now, I'm going to color code. We also have this part. And, so and we've got to multiply now. And they've got to match the number on the gold ball. So that's just going to be, what we'll do on that is that's just a probability. That's just 1 out of 34 for that one, right? Does that make sense? So probability of 5 all 5, right? Let's just put probability of all 5. Okay. Times all 5 white. Does that make sense how I'm writing it? We're going to do that times probability of the right gold one, right? I need to move this stuff over still. Still didn't leave myself enough room. We're just assuming that they're pulling from 2 different bowls. One has the gold balls. Come on. There we go. And one has the white balls. And then we're just going to multiply it and find out what we get. Now I wanted this to be green because that's the one we have as the gold is. I should have used yellow for gold, but I didn't. All righty. Any questions on the setup I have here?
No.
Okay. So only one of these little things that they're choosing here is going to work. And then only one ball is going to work. So we have 1 over all of this. So you can do this by hand or you can just use the calculator to do it. So this is 43 over 43 minus 5 factorial. And 5 factorial. Okay. All of that is times 1 over 34 still. And then let's simplify this one. So 43, we're going to have 43 times 42 times 41 times 40 times 39 times 38. Okay, and then all of that's divided by 38 factorial times 5 factorial. And then it's still times 1 over 34. Now, this is going to cancel. here. Let's do it in red. And then the 5 goes in, we could take it out of 40, I guess, and make that an 8, right? Oh, no, that's 5 factorial. Oops. Let me write that out. Let's take this. 5 factorial, we get 120. So let's just work it out. Okay. And so now we can take out a lot of stuff. You can stop me if you have a question. How are you doing right now?
I'm fine.
Okay, so we have 5 times 4 times 2, that's 40, right?
Mm-hmm.
And then 3 goes into 39, 13 times. And so let me continue. And I'm going to move this stuff over one more time. Okay. So I have 1 over 43 times 42 times 41 times, times 13. And then it's times 1 over 34. So you can actually just put that with it, right? And let's just see what that is. And it should be a really small number. You know, it should have a big fraction on the bottom because we're talking about lottery, right? It's very bad odds when you play the lottery. I get 1 over 32,728,332. Yeah, that's pretty bad. We can always double check too with the calculator. I want to show you, you can put this in, okay, just to make sure, because there's a lot of room to make a mistake there. So we have this alpha y equals, we're going to do 1 over, go to math and probability again. And we're doing a combination. And it was 43, choose 5. And times, it was 1 over 34. Is that what it was?
Oh.
Was it 34? Yeah. Let's see what we get. Make sure. Okay. So see how it's making it a decimal? A lot of times on the answer, they want it to be simplified fraction, right? So go to math and you can actually change it to fraction. Okay, something is not right then. Why is it giving us a limitation like that? It's acting like it's irrational or something, and it's not. Well, let me check that answer here. So 43, choose 5. Let's see what that is. Okay, and we could do that times 34. Is that what we had? That's the same number we had, right? Yeah. 332. All right, so we'll put that into the computer. 1, and we got 32728,332. Okay, so it took it like that. Yeah, I don't know why. That's sometimes the limitation on the calculators. They do weird stuff like that. So that's why it's important to know how to do it by hand, and then only use the calculator to check your work. But then you got to know, like, if you do get something weird, how do you get around that? So this, I just multiplied the denominator. Any questions here?
No.
Okay. Probably have time for one more, and then do you still want this section, or is there another one you wanted to look at, or up to you. Or certain problem.
Can we do one problem from section 11.6?
11.6, yeah. Let's just go out. Like this one. Not bad though. So your delta, one card from a 52 card deck, the probability that you get a 9. You just have to know like what cards in a card deck. How many 9s are there? Do you know what a card deck looks like playing cards?
No.
Okay. Let me just show you. So playing cards. So a card deck, let's see, show, this is a good image here. See? Not showing all of them now. It does. Ace, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. It goes all, it doesn't do 11, 12, but Jack kind of counts as 11 on a lot of games. Queens count as 12 and Kings 13. But anyways, it counts all the way aces up to kings. But you have 4 suits. You've got diamonds, you've got clubs, spades, and hearts. So each of those suits is going to have a 9. So you got 1 9 here, 2, 3, and 4. So it's 4 out of the 52. So there's 4 of them out of 52. Oh, that you're not delta 9. Oh, okay, I didn't see that. We can still use this though. We can use the complement rule. I didn't read this part. So this is this reduces to 1 out of 13. Okay. Probability not 9. We use the complement rule. That's going to equal 1 minus the probability of 9. So it'll be 1 minus 1 over 13. Does that make sense? Because the other cards that you have, and we'll actually check the answer in a second. I'll show you a different way. This is one way, though. This is called the complement rule. Complement rule. So that's going to be 1 is just 13 over 13, right? Minus 1 over 13. That's going to be 12 over 13. These are all 9s right here. This one, this one, this one, and this one. All right. So we get 12 out of 13 when we do that. But the other way to think about that, you can use a formula, but a formula just gets you so far, like you don't understand it all the way. So the reason we're subtracting is because these all together, what do the probabilities add up to? What do the probabilities add up to? What does probability always add up to? So probability not 9 is going to be all the other ones. So that's going to be 48 cards, right? Not 9, not 9s. Okay, divided by the total. But then when you reduce this, this actually reduces by 4 to 12 over 13. So you could sit here and count out all these other ones, right? There's 48 of these together here, right? All of those. Or, and then put it over 52, or you can just be smart about it and count these 4 and subtract that probability from 1. Because this is, well, this is 32. This is 16. All right, do you have any questions here?
No.
Okay. All right, let's look at, we can try to do one more and then we'll wrap it up unless you have to go. not delta heart. It's very similar to the last one.
Mhm.
It's just hearts. There's 13 of them. I'll just show you. I'm not going to work it out, but I'll just show you. Hearts are this row right here. There's 13 of them. So 13 out of 52. Okay, I'll go ahead and just put this one because it won't take long. We don't need to explain it as much. All right, so there's 13 hearts. And then there's 52 cards. So probability, not heart. Is equal to 1 minus probability of heart. So it's that same complement rule we did earlier. So it's going to be 1 minus probability of heart. There's 13 out of 52, right? 13 out of 52 reduces to 1 out of 4. So it's 1 minus 1 out of 4, which is just 3/4. Is that understandable?
Yeah.
Okay. All right, let's see if there's a harder one.
Can we do that one?
This one? Yep. All right, so this is Scrabble. The game of Scrabble has 100 tiles. I don't ever play this. This is like making words. The diagram shows a number of tiles for each letter. So there's 9 A's. I don't know what the little 2's mean. Points. Oh, that's the point value. Okay. And the letters point value. 1 tile is drawn from Scrabble's 100 tiles. Okay. If 1 tile is drawn from 100 tiles, find the odds in favor and the odds against selecting an X. So an X, there's only one out of 100, for the X.
Mhm.
Let's write the probability of X. That's a good starting point. It's just 1 out of 100. Okay. And then for odds, so we have the number of unfavorable outcomes. That's going to equal 100 minus 1, right? Which is 99. So 1 to 99, we'll write that like that. So this is going to be favorable to unfavorable right here, because we have 1 favorable to unfavorable, right? Because there's 99 unfavorable. And 1 favorable is just the X. Does that make sense?
Mhm.
And then, so that was the favorable odds we had, right? It's just 1 to 99. And then we want to find against it, are just going to be 99 to 1. We just flip it.
Mhm.
But I think it helps to write it as a probability first, like that.
Mhm.
And let me just write this. So this is odds against. We'll write it that way. Odds against. And the way they're wording it is a little different than what I have worded. But odds against, and then this is odds in favor. So you start out with the favorable ones. Okay. Hopefully this is a good amount. If you don't feel like you're ready, I opened all your tests up anyways till Friday, and we have the final exam review on, what day did I make it?
On Monday?
Monday night. Do you think that's a good time, Monday night, for the final exam one? And then we can continue answering questions if you have any.
Mhm.
Okay.